I don't know if some of you have missed yesterday's program because it did get posted pretty late, but we covered the August 10th derecho in Iowa and Illinois. Certainly a historical weather event, so check that out if you get a chance. For today, our eyes turn back south, getting a little bit active in the tropics once again. Tropical Depression 11, still way out there in the Atlantic. But as we can see, that's heading up into the region just north of Puerto Rico. And there's an outside chance that could affect the East Coast sometime later next week. But that's still a long ways out, and the system could always recurve back to the north. Nothing else of interest on the 5-day tropical weather outlook, so let's check out the North American weather. I think a good place to start is with the 250 millibar upper level chart up at the top of the troposphere. What do we have here? Well, doesn't look like much of an easterly pattern. The past week has been dominated by a very progressive zone of westerly flow throughout much of the U.S., and the easterly flow just confined to South Texas there. A preliminary look at where the subtropical high pressure is. I think we can see anticyclonic circulation right there. So that would put it over southern Alabama. This area here looks to be under just part of that ridge. Don't have any data offshore, so we'll have to go to the models for that. And looks like we do have a center just south of Douglas, Arizona. So these subtropical highs a little further south than where we typically see them. Often in the late summer we'll see them come up in this area or up in Arizona, New Mexico, but we don't have that today. Looks like we have a long wave trough pretty much over the U.S. This whole area is kind of a depressed area of heights. And embedded in that are a couple of major troughs, one on the west coast and another in the Great Lakes and Hudson Bay region. And looks like we have a cutoff high up in the Northwest Territories. Another way we can visualize the upper level flow is with the Hove Molar diagram. These are produced by Dr. Ventris at University of Albany. You can put that in a search engine and find these. And this is the temperate latitudes here in the northern hemisphere, 200 millibars, so it's near the top of the troposphere, and we're looking at a plot of longitude on that axis. So everything in here is a Europe and West Asia. Asia proper is right here. North America is located in here, and then the Atlantic Ocean is way over here. Then we have a date plot. There's May and June, and then going forward we've got about 3 months of data bringing us to the current time. The scale below shows north and south transport of wind. So the red shades are going to be a northward transport, usually warm air advection, and this will be southward transport. And what we see here is over the Pacific, the flow is very meridional. And that's certainly the case. You can see out here over the Pacific, pretty good oscillation of the flow. And by tracking that over time, we can see how progressive or stagnant the flow is. And pretty much everywhere around the hemisphere, over the past 2 weeks, it's been pretty progressive. You can see the movement represented by those wave trains there. So certainly not a blocking pattern. If you want to see a blocking pattern, we can see a blocking pattern in North America back in late June right there. The wave trains are kind of retrogressing a little bit. So these diagrams are kind of useful for seeing what's going on and what kind of waves may be heading our way by looking upstream in terms of longitude and time. The polar front jet coming on shore around Portland, then curving up into Canada and picking up another segment there near James Bay and Labrador. Looks like we have a split flow, another segment. This could be a subtropical jet right there, running from California to Kansas. Another segment out over the northeast, probably from that departing front. And now that we have a very good idea what's happening, let's look at the surface chart. And we'll just start out with this Canadian analysis because, it looks kind of cool. Also, we can take a look at their placement of the fronts. They've got one over the Maritimes down to Boston and Philadelphia. What else does it show? Well, there's a system right there over Alberta. They don't have a front analyzed, but we'll take a look at the surface data and see what's going on. Before we start looking at the U.S. weather, I think a good place to start is the radar. This is yesterday morning before dawn. We run that forward. You can see a lot of storm activity there in Arkansas, down to Mississippi and Alabama. And then we get up to this morning. Still a lot of MCS activity there in Arkansas. Let's get a closer look at that. And this starts out yesterday just after dark in the evening, and almost certainly these are laying down some large cold pools. Also, the stuff in Oklahoma is doing the same thing. And you can see right there, it's really the Arkansas storm that keeps going overnight, but outflow boundaries all the way offshore, and that's disrupting the onshore flows this morning in the Gulf Coast region. And lots of air mass storm activity lighting up there in the southern Appalachians down into Georgia. You can see a few hours ago there wasn't really much at all. So that's classic heating, moisture, everything coming together and producing storms across the southeast U.S. And there's what things look like at this hour. Most of the Arkansas stuff has shut down and we're left with kind of an orphan anvil, but you can see right there the outflow. So that's going to be a location we're going to watch today for new storm development. It's a little less clear what's going to be happening back in here. There may be a outflow boundary right there in Mississippi. Most of the other boundaries are off the Florida coast. Looks like there's a new one there heading towards Gainesville, and another good one there, and the rest of it, just take your pick of whatever area you're interested in. A lot of mesoscale stuff going on across that region. And there's what we have for the surface analysis. Still looks like an old front there in Georgia. Outflow boundaries off the coast right there. In fact, that may actually curve further south like that. I mostly just went off this one wind plot where it was out of the southeast. But there's that boundary there through northern Louisiana up to north of Dallas and up towards the Oklahoma City area. In the southwestern U.S., the progressive prevailing westerlies still dominating the weather through much of that region right there. And when that happens, it's hard to get monsoon moisture back in Arizona. We do have 50s there, but not the 60s we saw about a week or two ago. So that's going to limit some of the thunderstorm aerial coverage. Looks like the dry line is in place throughout the high plains down into Texas. We have 70s impinging on the dry line around Woodward up to Dodge City. So given those 70s, I would expect maybe a few storms in that area. SPC doesn't really see much along that dry line except up in Nebraska, so presumably there's some problems there maybe with moisture depth or capping. And we can see the high-resolution rapid refresh not going for anything in Kansas. So let's sample the atmosphere around Dodge City and see what the problem is. Well, that's some decent moisture. 60s all the way up. But there's the problem there. Very strong cap. 700 millibar temperatures, 16 Celsius. That's going to be a tall order to break that. So even though we do have the instability, the convective inhibition is pretty high, and this is an example of where you really have to look at the mixed layer method for the real story. A lot of people get keyed in on the most unstable method, the surface-based method, but that's not going to apply here because as you build your parcels up, you're transporting more of this dry air down to the surface, and that's going to get entrained in the parcels. And since the 700 millibar temperature is a factor, We want to look at some horizontal plots of temperature, and you can see that little blob of warm air cruising right over to where the moisture is trying to get active and just shutting everything down. And then by this evening, 22, 23Z, you can see we've got temperatures of 16, 17 Celsius, so that cap is just holding on strong in that region. And there we see the moisture field there in southwest Kansas. It's really not too bad. But it's up against that very strong cap. Now where we do have storms is in the elevated regions of Colorado there in the Rockies. And looks like the Mogollon Rim and parts of northern New Mexico should see some activity later today. And even up in the higher terrain of Nevada there near Ely and Austin. There's the surface analysis for the northwest. That system we had in Alberta yesterday is starting to move eastward into Saskatchewan and bringing a cold front down into northwestern Montana. And looks like with that downslope flow in Montana, temperatures are up quite a bit, up into the 80s at this hour, and we've got what looks like a heat low down there in southeastern Montana with a trough extending south into Nebraska. Warm front down into North Dakota, and I'm not sure if we have any, so yeah, I think we do have a little severe weather potential along that dry line. Atmosphere there a little more uncapped in 60s dew points. That's not great, but it's probably at least enough to support some development. And I might be inclined to bring that front a little further south through Washington. I'd have to look at more data to figure that out. Things getting a little active there in the northwest. You can see those storms and cumulus showers coming together there in southern Montana. And this looks to be like a baroclinic cloud pattern. We can see that a little bit better by switching over to the infrared. And yeah, that's a classic baroclinic comet cloud. Let me try doing that in red there. So you see that right there? That's associated with temperature advection and baroclinic development. Back behind it, we got the cold air advection coming into Portland. So yeah, maybe I would draw that front a little further south. And then up to the north, we've got this shield here being fueled by warm air advection and dynamic lift. And then switching over to the northeast U.S., it looks like they're kind of in between systems. We do have the tail end of that front still along the northeast coast, and looks like it's producing some thunderstorms around Philadelphia, back into central New Jersey. And looks like we have a similar upper level disturbance approaching that area. That looks like another comet cloud, and let's check that out on visible imagery. And you can see it's just fibrous cirrus, but there's a lot of it, and it looks like it is organized into a axis along some sort of shortwave moving across that area. And there's the map for the northeastern U.S. Yeah, it looks like a very large high-pressure area, not very strong at all. And I think the next big change to affect the area will be warm air advection setting in across the western Great Lakes as that next front from the Canadian prairies approaches the area. And it does look like things have returned to normal in the Hudson Bay region where they had those 80s and a couple 90s out in this area, and now they're down to their seasonal normals around the 50s, but still a little warm air hanging on in Labrador there, 81 at Goose Bay. I don't think you hear that mentioned very much at all. Weather in Labrador, Newfoundland, I think to a lot of TV weather, it just does not exist as far as the U.S. and Canada are concerned. But anyway, yeah, cold air setting back in across the Arctic, and that's what we like to see. All right, so let me go ahead and get this posted. Last night's file was 1.2 gigabytes, and that took forever to upload, so we don't want to repeat that today. So we'll get you this clip going, and we will see you all tomorrow. Take care, and thank you very much to those of you supporting the stream, and have a good one. Bye-bye.